NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math tutorial video. Today we're going to explore an important algebraic identity, the square of a trinomial. Let's begin by understanding what we're trying to prove. The theorem stated in the image is the square of the sum of three terms. This is an extension of the more familiar square of a binomial formula. Now, let's examine the proof of this theorem step by step. We'll start with the expression on the left side of the equation, the square of the sum of a, b, and c. In the first step of our proof, we'll regroup the terms. We can rewrite the trinomial as a binomial by grouping a plus b together and then adding c. For the second step, we'll apply the binomial square formula. This states that the square of a sum of two terms equals the sum of the squares of the terms plus twice their product. Applying this to our expression, we get the square of a plus b plus the square of c plus twice the product of a plus b and c. In the third step, we expand the first term using the binomial square formula again. The square of a plus b equals a squared plus b squared plus 2ab. In our fourth step, we apply the distributive property to expand the term 2 times a plus b times c. This gives us 2ac plus 2bc. Finally, we can rearrange the terms to match the right side of our original theorem. We group the squared terms together, followed by the cross product terms. This gives us a squared plus b squared plus c squared plus 2a b plus 2ac plus 2bc, which is exactly what we wanted to prove. Let's visualize this formula with a geometric representation. Imagine we have a cube with sides of length a plus b plus c. The volume of this cube can be calculated in two ways, either by cubing the sum or by adding up all the individual components. Let's try an example with actual numbers to see how this formula works in practice. Suppose we have a equals 2, b equals 3, and c equals 4. Let's calculate the square of their sum. To solve this, we'll substitute a equals 2, b equals 3, and c equals 4 into our formula. We have the square of the sum is equal to a squared plus b squared plus c squared plus 2, a b plus 2, ac plus 2bc. Now, let's calculate each term. 2 squared is 4. 3 squared is 9. 4 squared is 16. 2 times 2 times 3 is 12. 2 times 2 times 4 is 16. And 2 times 3 times 4 is 24. Adding all these terms together, we get 4 plus 9 plus 16 plus 12 plus 16 plus 24, which equals 81. Let's verify this result by calculating 2 plus 3 plus 4 directly, which is 9, and then squaring it, which gives us 81. So our formula is correct. Let's summarize what we've learned. The square of a trinomial a plus b plus c equals a squared plus b squared plus c squared plus 2, a b plus 2, a c plus 2bc. This formula extends the binomial square formula to three terms. We proved this by regrouping the terms and applying the binomial formula twice. We also saw how this formula works with a numerical example. This pattern can be extended to find the square of a sum with any number of terms. Welcome to this lesson on trinomial square expansion. Today, we'll learn how to expand expressions like the ones shown here using the trinomial square formula. Before we dive into the examples, let's understand the general formula for a trinomial square. When we have an expression of the form a plus b plus c squared, we can expand it using a specific formula. The square of a trinomial can be expanded as a squared plus b squared plus c squared plus 2 times a times b plus 2 times a times c plus 2 times b times c. This formula works for any expression with three terms being squared. Now, let's look at our first example. We need to expand the expression 2x minus 3y minus xy squared. To apply the trinomial square formula, we first need to identify the three terms. Here, a equals 2x, b equals negative 3y, and c equals negative xy. Let's apply the trinomial square formula. According to the formula, we need to first square each term. That gives you s. A squared equals 4x squared, b squared equals 9y squared, and c squared equals x squared y squared. Next, we multiply each pair of terms and double the result. 2ab equals 2 times 2x times negative 3y, which equals negative 12xy. 2ac equals 2 times 2x times negative xy, which equals negative 4x squared y. 2bc equals 2 times negative 3y times negative xy, which equals 6xy squared. Finally, we add all these terms together. Let's compare our expansion with the answer shown in the image. The image shows the expansion as 4x squared plus 9, y squared plus x squared, y squared minus 12xy minus 4x squared, y plus 6xy squared. This matches our calculation, so we've correctly expanded the trinomial square. Let's move on to the second example. Our second example is a minus b plus c squared. Again, we'll use the trinomial square formula. Here, the terms are simply a, negative b, and c. Let's apply the formula again. We'll square each term. A squared equals a squared, unchanged. B squared equals b squared, c squared equals c squared. Then we find the cross products. 2 times a times negative b equals negative 2 of 2 times. A times c equals 2ac 2 times negative b times c equals negative 2bc. Finally, we combine everything. A squared plus b squared plus c squared minus 2 of plus 2ac minus 2bc. Let's check if this matches the expected answer from the image. The image shows a squared plus b squared plus c squared minus 2 of plus 2ac minus 2bc. Our expansion is correct. Let's summarize what we've learned. The trinomial square formula allows us to expand expressions of the form a plus b plus c squared. Remember these key points. First, identify the 3 terms in your expression. Second, square each term individually. Third, find all possible cross products and multiply each by 2. Finally, combine all terms to get your final answer. Here's a helpful tip. Pay careful attention to negative signs when identifying your terms and computing the cross products. We want to expand the expression a cubed plus 3 a squared minus 2a all squared. To solve this problem, we'll use the square of a sum formula. We can think of this as squaring a trinomial where a equals a cubed, b equals 3 a squared, and e equals negative 2a. Now we'll apply our formula. A squared plus b squared plus c squared plus 2 times a times b plus 2 times a times c plus 2 times b times c. Now, let's evaluate each term. A cubed squared becomes a to the 6th, 3a squared becomes 9a to the 4th. Negative 2a squared becomes 4 squared. For the cross terms, 2 times a cubed times 3a squared becomes 6a to the 5th. 2 times a cubed times negative 2 becomes negative 4a to the 4th. 2 times 3a squared times negative 2 becomes negative 12a cubed. Now we need to combine like terms. We have 9a to the 4th and negative 4a to the 4th, which gives us 5a to the 4th. Let's write the final answer with the terms in descending order of exponents. Therefore, the expansion equals a to the 6th plus 6a to the 5th plus 5a to the 4th minus 12a cubed plus 4 squared. Now, let's look at our second example. We want to expand the expression to a minus 3b minus 2ab, all squared. Again, we'll use the square of a sum formula, but this time with 3 terms. For this example, let's identify a equals 2a equals negative 3b, c equals negative 2ab. Now we'll apply our formula. A squared plus b squared plus c squared plus 2 times a times b plus 2 times a times c plus 2 times b times c. Now let's evaluate each term. 2a squared becomes 4 squared. Negative 3b squared becomes 9b squared. Negative 2ab squared becomes 4 squared b squared. For the cross terms, 2 times 2a times negative 3b becomes negative 12ab. 2 times 2a times negative 2a b becomes negative 8a squared b. 2 times negative 3b times negative 2a b becomes 12ab squared. Now, we rearrange the terms in a more organized way. We'll group them by the power of the variables. Therefore, the expansion equals 4 squared minus 8, a squared b plus 4, a squared b squared minus 12, ab plus 12ab squared plus 9b squared. Let's summarize what we've learned about squaring binomials and polynomials. This is an important technique in algebra that helps us expand expressions like this one. Let's start with our first example, the square of 2 minus 3x minus 4x squared. To solve this, we need to remember the rule for squaring a polynomial with multiple terms. For any polynomial with multiple terms, we square each term and then add twice the product of each pair of terms. Let's first identify the terms in our expression. A equals 2, b equals negative 3x, and c equals negative 4x squared. Now, let's apply the rule for squaring a polynomial. We need to square each term and add twice the product of each pair. So, our expansion is a squared plus b squared plus c squared, plus 2 times a times b, plus 2 times a times c, plus 2 times b times c. Let's compute each of these terms. First, 2 squared equals 4. Next, negative 3x squared equals 9x squared. Then, negative 4x squared. Squared equals 16x to the 4th power. 2 times negative 3x equals negative 12x. 2 times negative 4x squared equals negative 16x squared. Finally, 2 times negative 3x times negative 4x squared equals 24x cubed. Now, let's combine all the terms to get our final expansion. We have 4 plus 9x squared plus 16x to the 4th power minus 12x minus 16x squared plus 24x cubed. Now, let's look at our second example. For our second example, we need to square the expression a to the 4th power plus 2a squared plus 3. Let's identify the terms. A equals a to the 4th power, b equals 2a squared, and c equals 3. Just like before, we'll apply the rule for squaring a polynomial. So our expansion is a squared plus b squared plus c squared, plus 2 times a times b, plus 2 times a times c, plus 2 times b times c. Let's compute each of these terms. First, a to the 4th power squared equals a to the 8th power. Next, 2a squared equals 4, a to the 4th power. 3 squared equals 9. 2 times a to the 4th power times 2a squared equals 4a to the 6th power. 2 times a to the 4th power times 3 equals 6a to the 4th power. Finally, 2 times 2a squared times 3 equals 12a squared. Now, let's combine all the terms to get our final expansion. We have a to the 8th power plus 4, a to the 4th power plus 9 plus 4, a to the 6th power plus 6, a to the 4th power plus 12a squared. Let's start with our first expression, the quantity 2a cubed minus all raised to the 4th power. Our first step is to rewrite this 4th power as the square of the square. So we have the quantity 2a cubed minus a squared, and then that entire expression is squared. Next, we'll expand the inner square using the binomial formula. Remember that for any binomial a plus b squared, we get a squared plus 2ab plus b squared. In our case, we're squaring 2a cubed minus a, so we get the quantity 2a cubed squared, minus 2 times 2a cubed times a plus a squared. Now, let's simplify the expressions inside the bracket. 2a cubed squared becomes 4a to the 6th. 2 times 2a cubed times a becomes 4a to the 4th. And a squared is just a squared. So we have 4a to the 6th minus 4a to the 4th plus a squared, and this entire expression is squared. Now, we need to square this trinomial. We'll use the binomial expansion and expand it as the square of each term plus all the cross products. The squares of each term are 4a to the 6th squared, which is 16a to the 12th, negative 4a to the 4th squared, which is 16a to the 8th, and a squared squared, which is a to the 4th. The cross products are 2 times 4a to the 6th times negative 4a to the 4th, which is negative 32a to the 10th, 2 times 4a to the 6th times a squared, which is 8a to the 8th, and 2 times negative 4a to the 4th times a squared, which is negative 8a to the 6th. Now, let's simplify this expansion. 16a to the 12th plus 16a to the 8th plus a to the 4th minus 32a to the 10th plus 8a to the 8th minus 8a to the 6th. Finally, we combine like terms to get our final answer. We have 16a to the 12th minus 32a to the 10th plus 16a to the 8th plus 8a to the 8th, which makes 24a to the 8th minus 8a to the 6th plus a to the 4th. Therefore, our final expansion of the quantity 2a cubed minus all raised to the 4th power is 16a to the 12th minus 32a to the 10th plus 24a to the 8th minus 8a to the 6th plus a to the 4th. Now, let's move on to our second problem, the product of two binomials a minus b minus c times b minus a plus c. First, let's recognize that this can be rewritten by factoring out a negative sign from the second factor. So we have a minus b minus c times negative times quantity a minus b minus c. Now we can recognize that this is the negative of the square of a minus b minus c. So we have negative times the quantity a minus b minus c squared. To expand this square, we use the trinomial square formula. We have the square of each term plus all the cross products. Remember that the square of a minus b minus c is a squared plus b squared plus c squared minus 2a b minus 2ac plus 2bc. Now, let's simplify this expression. We have the negative of a squared plus b squared plus c squared minus 2ab minus 2ac plus 2bc. Finally, we distribute the negative sign to each term. So we get negative a squared minus b squared minus c squared plus 2ab plus 2ac minus 2bc. Therefore, our final expansion of the product a minus b minus c times b minus a plus c is negative a squared minus b squared minus c squared plus 2b plus 2ac minus 2bc. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.